coldest part of our solar system. A hidden force appears to be disrupting the rhythm of space.
Totally dominates all of that region of space. Eats things that come near a guy, flings them into the sun.
It's evidence, some say, of a massive hidden world orbiting our sun.
So we think this thing is 5 to 10 Earth masses in size.
It is so dim. If you were to compare it with, say, like Jupiter, it's probably the difference between staring point blank at a stadium light versus looking at a firefly miles away.
Now, astronomers across the world are racing to be the first to lay their eyes on the sun's lost planet. If it even exists. It's never been seen, but there are astronomers who are convinced it's there. Some call it Planet X. Others call it Planet 9. A few years ago, no one could have even imagined that there might be another large planet silently orbiting the sun billions of miles past Neptune. But now, a new generation of telescopes is allowing astronomers to see far beyond what they could have ever observed before. Just a generation ago, even the most powerful telescopes in the world struggled to sense anything past the known planets.
When people first started looking for planets, asteroids, anything that moves in the solar system, they did it by taking pictures of the sky with giant glass photographic plates. Photographic plate is a piece of glass. You paint photographic emulsion on it, you put it on the back of the telescope, you take a picture of a huge swath of the sky.
Astronomers worked in complete darkness, painstakingly preparing image after image.
You put it on the light table, and you see it's full of thousands and thousands and thousands of stars, galaxies, and anything else that happen to be there. In this view, I probably see 100 stars.
Countless hours were spent comparing images taken from the same spot in the sky. Night to night, galaxies and stars held their positions. Planets, moons, and other objects circling the sun, however, would appear to shift. This is how the great discoveries of the 20th century, like Pluto, were made. Could there be evidence of one more planet hiding in a slide like this one?
The photographic plates, although they have these great historic data and historic value, it's not sensitive enough to have seen Planet 9, probably.
The story of the lost planet could only begin after more precise digital cameras were bolted onto the world's most powerful telescopes, beginning in the 1990s.
One of the first major discoveries that came out of this upgrade was the discovery of the Kuiper Belt.
With the 1992 discovery of the Kuiper Belt, a massive ring of icy debris near Pluto's orbit, astronomers finally had proof that there was something beyond the planets.
The moment those first few objects were discovered, it was clear that this is just the tip of the iceberg.
By the end of the 1990s, we knew of hundreds of objects that were similar to Pluto in terms of their orbits.
Astronomers were now observing some 3 billion miles from Earth, but they weren't satisfied.
So as soon as the Kuiper Belt was discovered, people started saying, wait, maybe there's something else even further out there.
After years of scanning the night sky, Mike Brown would answer that suspicion with the discovery of Sedna in 2003.
The first hint that something was wrong, that the solar system had some additional tricks left up its sleeve, came with the discovery of the object Sedna. Sedna, as a physical body, is not too remarkable. It's just another icy ball, a little bit smaller than Pluto. But its orbit is completely wild. To go one time around the sun, it requires 10,000 years. And at its outermost reach of its orbit, it goes out to 1,000 times the distance between the Earth and the sun.
No one had ever seen anything like Sedna before. But what really puzzled scientists wasn't just the size of Sedna's orbit, it was the shape of Sedna's orbit.
The weird part about Sedna's orbit is it never comes close to the sun. This was weird because we thought to go on an elongated orbit, it needed to have gotten close to something and go out on a slingshot and come back around. But Sedna never comes close to anything. It was clear that there was something else in the solar system that we hadn't seen before.
Objects in our solar system aren't only impacted by the sun's gravitational force. They're pushed around by each other's gravitational force as well.
Turns out that it's the first clue to the existence of Planet 9, even though we tried really hard not to jump up and down and say it at the time, because we needed a lot more evidence before we were convinced that there was something out there.
Everyone realized that Sedna cannot be alone, right? There has to be an additional population of such bodies.
But for the next 10 years, search after search came up empty. Enter Scott Shepard at the Carnegie Institution for Science in Washington, D.C. Using the 4-meter Blanco telescope in Chile, he and his team began the deepest, widest survey of the outer solar system ever attempted. In a matter of days, they make their first discovery.
And we started observing, and this is what we see. We take 3 images of the sky, each image separated by about 2 hours. And we make a movie of those 3 different images. And you see background stars are these circular type objects, and they do not move over a few hours time span. We also see very distant galaxies, so they're the oval looking things here and here. What we find is this object here is actually moving relative to the background stars and galaxies. And so the reason that we found this object so interesting was because it was so distant. And it actually took another year of observations. We had to re-observe this object a few months later, and then again a year later to actually get the orbit for the object.
Shepard and his partner on the project, Chad Trujillo, nicknamed the object Biden and continue to study its orbit. What they find only deepens the mystery. Like Sedna, Biden orbits the sun, but never comes close to the known planets. They then analyze the orbits of about a dozen other objects found beyond the Kuiper Belt. They, too, had unusual, elongated orbits. Stranger still, when they compare all of these objects' orbits in 3 dimensions, they realize that they all share a common alignment along what astronomers call their argument of perihelion. An unknown gravitational force appeared to be stretching, clustering, and tilting the orbits of these distant objects. For Shepard and Trujillo, the data pointed to an uncomfortable conclusion.
It's kind of almost a crackpot type thing to say that there's a planet in the outer solar system. So we didn't really want to go that direction, but the evidence was there.
Caltech's Konstantin Batygin and Michael Brown were intrigued by what Shepard and Trujillo were suggesting.
That discovery was the inspiration for me and for Mike to go and look at this closer.
But before they could get on board with the idea of a new planet, Batygin and Brown needed to better understand the impact of the proposed planet's gravitational force on the outer solar system.
We looked at the data for a long time, and we realized that our theory of a planet made a prediction that in addition to these objects all elongated in one direction, there should be another set of objects elongated at 90 degrees to these and also twisted by 90 degrees. Those are weird orbits that nothing that we knew of in the solar system has. So I found these ones. They were twisted the way we thought they were twisted. They were really distant. I didn't know how they were pointed though, and so Constantine was in my office. I was like, Constantine, I found these objects. I'm gonna plot their positions on my screen. Press the button and they were, boom, exactly where our theory said they should be. I mean, I remember this moment. This is where it went in my head. A switch flipped from, this is a kind of cute idea that explains the data to, oh, there's a giant planet out there and we know where it is. the race was on to find it.
Typically, when you think of proof of something, you want to see a picture of something before you believe that it's really there. In the case of Planet 9, we don't have a picture of it yet. All we have for it for now is the gravitational evidence. But the gravitational evidence for it is really solid.
Batygin and Brown had found the evidence they were looking for, and this wouldn't be the first time a planet was predicted before it was ever observed. Because of the shape of Uranus's orbit, astronomers understood decades before they saw it that another planet, Neptune, must be orbiting nearby. A similar phenomenon could be observed near Jupiter.
Jupiter is a very massive planet that is just outside the asteroid belt. So we see clustering of asteroids. And so even if we never even saw Jupiter, we would know Jupiter exists because we see clusterings of various main belt asteroids together.
The probability that we would see these elongated orbits and they would be clustered the way they are and they would be tilted the way they are, the probability is 0.2%. There is a 0.2% chance, a 2 chances out of 1,000, that what we see is just due to chance.
No matter how convinced these teams are that another planet is out there, until someone observes it, it remains only a theory. In a way, astronomers are back to where they were when telescopes were fitted with glass plates, their technology struggling to keep up with their biggest ideas. To fully grasp the challenge of finding the lost planet, you need to understand the scale of the known solar system.
So imagine these are the orbits of the 8 major planets that we know of. And here's Neptune's the most distant orbit known. So if we were going to plot Planet X's orbit on this graph, its minimum distance where we think the Planet X is out this distance.
It's estimated that the planet's orbit takes it some 30 billion miles from the sun.
This now, the sun would just be another star in the sky.
Their challenge now is to narrow down where on this predicted orbit to direct their telescopes. It's a daunting task, to say the least.
So what we're going to do now is do a little scale demonstration of looking for Planet 9 with a terrestrial telescope. We're going to go and walk about 100 meters that way to get you a sense of scale of how big the field of view is. The biggest camera we use is called Hyper Supreme Cam on the Subaru telescope, and it covers about 1.5 square degrees of the sky, which is about this as viewed from 100 meters away. So even though this is a big field of view compared to other telescopes on Earth or even in space, this is still just a tiny percentage of the full night sky.
Observation, astronomers have a near infinite number of targets to choose from, each loaded with celestial objects.
The second challenge is that Planet 9 is so far away that it appears really, really, really small, really tiny on the field of view. So to give you a bit of a sense of scale, I have my surgical tweezers here. I'm going to try and create a little model of how big Planet 9 would appear on the telescope. We have this little white piece of tape. This is actually a little big, maybe by a factor of 1,000 compared to how Planet 9 would actually look. But the real issue, the biggest of the challenges, is the third one, which is that Planet 9 is exceptionally dim. Because when you take an object and move it really, really, really far away from the sun, it just does not reflect that much light. So a much better analogy than this white piece of tape here would be a black piece of tape. So there it is. I'm sure it's completely invisible to you, but I promise you it's there. And that's a pretty good representation of what it's like to look for Planet 9. You're looking from 100 meters away at a patch of sky this big, and you're looking for something that is just painfully, just exceptionally dim.
How Planet 9 got so far removed from the other planets is one mystery, however, astronomers think they've solved.
Main theory is probably that it formed in the giant planet region, probably formed near Jupiter and Saturn. And I like to call it the runt of the giant planet family.
The early evolution of the solar system is actually a very violent and chaotic place. Probably what happened was Planet 9 came a little too close to Jupiter or Saturn and got scattered out into this long period orbit.
Pushed far beyond the gravitational reach of its siblings, the ejected planet soon establishes itself in its new 20,000-year orbit. A relic from a different time and place.
Most likely, if it formed in the giant planet region, it formed of 50% rock and 50% ice.
Out here, the gravitational pull of this rocky, icy mass would be too much for other objects to handle. Playing the role Jupiter played among the known planets, Planet 9 starts clearing a path through the outer reaches of the solar system.
Any of these smaller objects, if it ever got close to the planet, it would basically be ejected from the solar system. Gravitationally, the planet would swat it like a fly.
It dominates more of the solar system than all the other planets put together. Nothing in the outer part of the solar system is safe for long from Planet 9.
Not even Sedna and Biden and the other extreme objects, which first revealed the possibility that this planet could be hiding in our own backyard.
Those are the only ones that haven't yet been destroyed by Planet 9, because it just hasn't had time to eat everything yet. I think about this sometimes. If we existed 4 billion years from now instead of right now, we wouldn't be able to know that Planet 9 was there, probably because nothing would be left in its region of sky.
Astronomers understand Planet 9's past. They can predict its future. But where it is right now remains a mystery. A mystery that the teams from Caltech and the Carnegie Institution for Science are racing to solve.
Our survey is trying to cover as much sky as possible to very faint depths, but we're limited by our technology and our telescopes.
Shepard and Trujillo's strategy is to keep scanning the sky, looking for other objects like Sedna and Biden to help point the way to the lost planet.
We've covered about 30% of the sky, but we're still only scratching the surface. We want to find the planet, and we're looking for the planet. The main goal of our survey is to find more of these smaller objects that can better narrow down the orbit of the planet.
Over the past 4 years, I have spent nearly all of my personal research time looking for Planet 9. There's nothing else that is nearly as important to me personally, emotionally, scientifically as finding this planet.
And for Mike Brown, history shows that there may be one more surprise twist in this story. Planet 9 may already have been observed.
Somebody has taken a picture of it already. The reason I'm convinced about this, actually, is because every major body that's been discovered in the solar system for the past 200 years, literally, has been seen many, many years before its discovery. Uranus was observed for 91 years before people went back and found previous observations up to 91 years earlier, 21 different times. Neptune was predicted by Leverrier, found by Gall. It was observed by Galileo Galileo drew in his notebook a little star that turned out to have been Neptune. Pluto was seen 16 years before its discovery. And the trick is not to take the picture, but the trick is to figure out which one of those little spots that just looks like a star is actually not a star, but actually your object.
No one's life is going to change because there's an additional planet in the solar system really, really far away. But it would completely redefine the scale of what we think of as our cosmic home. And human beings have always been explorers. And understanding our cosmic home is something that everyone wants to do. It's weirdly wired into our DNA.
If or when the sun's lost planet is finally discovered, it'll be a triumph of science, mathematics, and collaboration. But for now, it remains invisible. A theoretical planet on a lonely, epic journey around the sun, waiting, it seems, to be discovered and to upend our view of the solar system.